Good morning, everyone. So today we are gonna be talking about integrals involving natural, logarithmic, and exponential functions. So we have here three formulas or three rules that we have to follow. First one is the integral of dx over x that is equal to the natural logarithm of the absolute value of x plus c. For the second one, this is for the exponential functions. That is the integral of e to the power of x dx that is simply equal to e to the power of x plus c. Third, this is for a constant. That's the integral of a to the power of x dx that is equal to a to the power of x over ln, the natural logarithm of a plus c, such that a should not be equal to 0 and a should be greater than 0 and a should not be equal to 1. So let's try some examples. By the way, for the first rule for the integral of natural logarithm, one time one of your classmates asked me, so if for example we have the integral of 1 over x dx, so someone asked, can we apply the rule, the power rule for the integrals? The answer is no. Why? If we solve for the integral of this one using the power rule, this is what it will look like. So that is the we can transform that to the integral of x to the power of negative 1 dx. Now using the power rule, that will be x to the power of negative 1 plus 1, and the denominator is also negative 1 plus 1 plus c. Now negative 1 plus 1 will give us 0, right? And if the denominator is 0, therefore the function will be undefined. Therefore, for this given example, we cannot use the power rule. That is why we have the rule for the natural logarithm. So, given if we have the integral of 1 over x dx, that will simply be the natural logarithm of the absolute value of x plus c. Okay? Number 2, for example, we have the integral of dx over x plus 2. So that will simply be the natural logarithm of the absolute value of x plus 2 plus c. Now for number 3, we have the integral of dx over 2x minus 3. For this given example, we can apply the U substitution method, which we have discussed last time. So let u be equal to 2x minus 3. Now du is the derivative of u, that will simply be 2 dx. Now substituting, or going back to our function, we can rewrite that one as the integral of 1 over 2x minus 3 dx, right? Now our u is 2x minus 3, but here our du is 2 dx. So we can transform this one just like what I taught you last time. We can rewrite that as the integral of 1 over 2x minus 3 times 2 dx. Now, since we have transformed this one, we need to put 1/2 outside of the integral symbol so that we can offset 2, because 1/2 times 2, that will still be equal to 1. So therefore, that is 1/2 the integral 2 dx is du over u, right? Now, following the formula for the natural logarithm, that's 1/2. The integral of that one is ln, the absolute value of u, plus c. Now, going back here, that's 1/2 ln, the absolute value of u is 2x minus 3 plus c. Let's have example number 4. That's the integral of x dx over x squared minus 1. Now, same with example number 3, we can apply U substitution. So, let u be x squared minus 1, du is, that is 2x dx, right? Now, this is our u, our du is 2x dx, so we can transform that one. That can be the integral of 2x dx over x squared minus 1. Now, since we put 2 here, we need to put 1/2 just to offset 2. Okay. Now, substituting or using U substitution, that's 1/2 the integral of 2x dx, that is du, x squared minus 1, that is u, right? Now, applying the rule for the natural logarithm, that's 1/2, that is ln, absolute value of u, plus c. Now, going back to our original function, our u is x squared minus 1 plus c. Okay? Now, if you have any questions, I will just inform you how you can address, or how you can ask those questions so that those will be addressed. Number 5, for example, we have the integral of x squared dx over 1 minus 2x cubed. So again, using U substitution, let u be equal to 1 minus 2x cubed. Now, du, that is negative 6x squared dx. Going back to our function, our u is 1 minus 2x cubed, but our du is negative 6x squared dx. So we need to transform that one. So that will become negative 6x squared dx over 1 minus 2x cubed. But since we put negative 6 here, of course, we need to put negative 1 over 6 outside of the integral symbol. Okay? Using U substitution, that's negative 1 over 6 integral, that is du over u. Applying the rule for the natural logarithm, that's negative 1/6 ln absolute value of u plus c. Now, going back, value of u is simply 1 minus 2x cubed plus c. Okay? Let's have example number 6. Example number 6 is the integral of x plus 2 over x plus 1 dx. Now for this, we cannot apply U substitution right away. We need to transform the function first. Now, the function can be rewritten as the integral of x plus 1 over x plus 1 plus 1 over x plus 1. Why? Applying the rule for rational expressions or rational numbers, diba? X plus 1 plus x plus 1 for our denominators is simply x plus 1. Now for the numerators, x plus 1 is simply x plus 2. Now further rewriting, that can be the integral of quantity of 1 plus 1 over x plus 1, right? Because x plus 1 over x plus 1 is simply 1. Now applying the distributive rule for integral, that's the integral of 1. So the integral of 1 is simply dx. Distributing dx plus the integral of 1 over x plus 1. Now the integral of dx is simply x, and the integral of this one, same with our example earlier, that is the natural logarithm of x plus 1 plus c. Okay, so again, if you have questions, maybe you can send it in our group chat so that I'll be able to entertain those questions. Now for example number 7, let's proceed to exponential functions. Again, the general rule is the integral of e to the power of x dx is simply e to the power of x plus c. So for example number 7, let's have the integral of e to the power of negative x dx. Now using U substitution, we can let u be equal to negative x. Now du, that is simply negative 1 dx, or simply negative dx. Going back to our function, since our du is negative dx, we can put negative 1 outside the integral symbol. That's e to the power of negative x, that will be negative dx. Okay, now substituting, that's negative integral of e, negative x is u, and negative dx is du. Now since we have this form, therefore that's the integral of e to the power of u du is simply e to the power of u plus c. Now u is equal to negative x plus c. Okay, let's have example number 8. We have the integral of e to the power of 3x dx. Again, using U substitution, let u be equal to 3x. Now du, that is 3 dx, right? So transforming the function, so that's integral of e to the power of 3x, we can transform that to 3 dx, but again we need to put 1/3 outside of the integral symbol. Now that's 1/3. Substituting u, that's e to the power of u du. Now, applying the rule for the integral of exponential functions, that's 1/3 e to the power of u plus c. Now, going back substituting, the value of u is 3x plus c. Next, we have example number 9. The integral of e to the power of 1 over x squared dx. Again, by using U substitution, we can let u be 1 over x. Now du, if you can still remember our rule for the derivative of a fraction, or if you have a numerator and denominator, or for division, that is low d high over high d low over low squared, right? So low, that's x d high, derivative of the numerator, that's 0 because the derivative of 1 is 0, minus high, that's 1, derivative of the low, x, that's also 1, over low squared, which is simply x squared. Now simplifying, that's 0, that's negative 1 over x squared dx. Now going back to our function, we can rewrite that as the integral of e to the power of 1 over x times 1 over x squared dx. Now this is our u. Now our du is negative 1. So you can put negative 1 outside of the integral symbol. E to the power of 1 over x. We can transform that into negative 1 over x squared dx. Using u substitution, that's e to the power of u, that is du. Applying the rule for integral of exponential functions, that's negative, that's e to the power of u plus c. And u, going back, that's negative e to the power of 1 over x plus c. Okay? Next, example number 10, we have the integral of e to the power of x plus 1 cubed times e to the power of x dx. Again, for that, we can use or apply u substitution. So let u can have our integrand, that's e to the power of x plus 1. Now du is simply e to the power of x dx, because the derivative of e to the x is simply e to the x. Now, going back to our function, that is the integral of, that is our u, it's u cube, right? So that's u cube, then this is du. Now for this certain example, we can actually apply the power rule. So that's u to the power of 4 over 4 plus c. Why 4? Because 3 plus 1 over 3 plus 1, okay? So that is for the u substitution, but still we need to go back to our original values. So u is e to the x plus 1 to the power of 4 over 4 plus c. Let's have example number 11. This will be the last example for exponential functions. integral of e to the power of 3x plus 4 dx. So let u be 3x plus 4. So du is simply 3 dx, right? Now we can transform the function, that's the integral of e to the power of 3x plus 4 times 3 dx, but again we need to put 1/3 outside of the integral symbol. Now using U substitution, that's the integral of e to the power of u, that is du. Applying the rule for exponential functions, integral of exponential functions, that is simply 1/3 e to the power of u plus c, and e to the power of u is simply 3x plus 4 plus c. Now let's have an example for the integral of the natural logarithm of a constant. So going back, the rule was the integral of a to the power of x dx, that is equal to a to the power of x over the natural logarithm of a, such that a is greater than 0, a is not equal to 1. So let's have the integral of a to the power of 2x dx. Now still applying U substitution, let u be equal to 2x, and du can be, or du is 2 dx. Now going back to our formula, or I mean the original function, we can rewrite that one as integral of a to the power of 2x times 2 dx, but we need to put 1/2 outside of our integral symbol. Now that is equal to 1/2 the integral of a, 2x is equal to u, 2 dx is du. Now since this is already in this form, this one, therefore that's 1/2 a times a to the power of u over ln a plus c. Now that is 1/2 times a, the value of u is 2x, over ln a plus c. So that's it for our discussion on the integrals of natural, logarithmic, and exponential functions. Next time, I will be discussing about the integral of trigonometric functions.